All right, so today we are going to talk about Profibus and its sibling Profinet. Profi, yeah. You gotta love these terminologies, don't you? All right, so Profibus, the overview. It is the process field bus. So they took the PRO from process, the FI from field, and the bus from bus. So it's Profibus. All right. Um, this was first promoted in 1989. So before many of you guys were born. All right. Um, yeah, not too long. Yeah. Anyway, it is a was first published as part of the IEC 61158. Now, if you don't know what IEC is, that is the International Electrotechnical Commission. All right, so anytime you hear the word IEC, it is that. It's just kind of like standardizations, trying to make things, keep our life simple from one thing to the next type of thing going on here. This is a single cable connection, all right? By default, we are going to be using a DB9 connector. Now, if you guys remember what DB9 is, hopefully you do, but just in case you don't, it's gonna let me draw today. Of course not. Now, can I draw? Oh, don't you just love it? All right, anyway, a DB9, it's, we've got something like this going on, so it looks kind of like a D. And you've got 5 pins and then 4 pins. All right, so the outside of the connector is shaped like a D, and there's 9 pins, DB9. All right. Another option that you might see is a 12 millimeter quick disconnect. Is possible there. This is going to be based on the world of serial. Most of these protocols are based on serial, either RS-232 or RS-45. I always find that interesting. It's just like, oh yeah, we're just modifying the RS-45 world. Nothing too special. As I've been doing research on a lot of these things to come up with labs for you guys, I'm like, okay, let's try to emulate this with some Arduinos instead of having actual process equipment. And it's like, oh well, we could do that, but I need RS-45 chips. It's like, this one needs them, and that one, I'm like, you got it. I've been freaking using RS-45. So I need to buy some RS-45 chips. It's not going to happen this semester unless I just buy on myself, which I might do. But at this point, anything I try to buy won't get here till after this semester's over for HCC. So that's a problem for another day. Now, another fun part about this is usually we're going to have a purple cable. That's going to help denote Profibus. Why purple? I don't know. I don't think it's in the standard that you must use a purple cable. All right, this is one of those things that it's really any cable will work. Not carrying that much voltage or current or things like that. Probably some 22 gauge wire would be perfectly fine depending on the distance you're traveling. But normally it's just big hunkin' purple cable. I'd say the outside diameter is I don't know, half an inch or something of the whole cable itself. The inner wires obviously aren't that big, but I was just like, oh, this is pretty standard that they're saying it's a purple cable. And to be fair, the one thing I've actually seen with Profibus did use purple cable. So I gotta give them credit for that. All right. But anyway, so this is part of the open and vendor independent world, the OVI. All right. This does ensure that devices from a variety of different vendors can communicate together easily and effectively. All right. Now, here in the US, Profibus isn't used super often. And I'm pretty sure the reason for that is we don't use Siemens PLCs all that often here in the US. Most of what's being used in the US is Allen Bradley. If you're going to have to pick one manufacturer, it's Allen Bradley. Now, I don't have any data to back that up. That would be something worth having. So why don't we go ahead and quick look that up. All right, so that's the Europe one. Where's the US one? So here you can see Europe, that Rockwell and Siemens are pretty close. I don't know when this is also from. That is not here. This is 9 months ago that someone posted that picture. So here you can see they're both kind of equal as OEMs. Now, end users, Siemens just freaking takes off. So that is definitely something you want to think of. Now, if we look at the US one, you can see here, Rockwell OEM, freaking through the roof. And users, Rockwell's all Allen Bradley. is still pretty freaking high. All right, so that's why I was kind of saying that in Europe, Siemens is a lot. In the U.S., Allen Bradley Rockwell's still kind of the king, but that market share is starting to decline some. I think part of this is due to just the freaking costs of things. I know there's a local company who they freaking love Click PLCs. They're cheap, the software is easy to use, it's free, we don't have to go through all these stupid licensing, They're like, we're perfectly happy with Click. But I have to tell you, I've used the Click software. I am not a fan. Did I show you guys that already? I think I showed you guys. I think we pulled up a whole bunch of different PLC softwares and we talked about Click. But yeah, I was not a big fan of the Click software when I've used it. So, but anyway, so that one's kind of interesting. And here's a different other market share. And I think this is of like worldwide. But Siemens is just a little bit over Rockwell. Then we have Mitsubishi, Schneider, Omron is another big one. And you can kind of just keep seeing they just kind of keep going down and down and down. So, but I just thought that was kind of interesting. But yeah, in the U.S., I'd say Allen Bradley is kind of the king. That doesn't mean it's the go-to or the one that you have to use, because let's be honest, it's a PLC. They all get the job done. All right. The real question to me is, how's it connect to your network, your system of devices? All right. I think I've said this before, but if I am building a facility, I want at minimum same manufacturer of equipment on everything. I don't care if it's Siemens or Allen Bradley. I just want one of them. And then on top of that, I would ideally love the same PLC on everyone. So that way I don't have to have 13 different, backup PLCs in stock for when something happens. I have maybe 2 or 3 and I can go, oh, this one died. Okay, I just go over it, yank that out, put the new one in, download the code to it again, and I can walk away within, 15 minutes maybe, and have the machine running again. Where it's like, oh, that died. We got to call up this company, get an emergency order from them, which they'll either ship it out or someone from our company is going to drive 4 hours to go get it. No, not my ideal. So anyway, yeah, so this is open vendor. That's nice. Siemens in Europe, definitely kind of the go-to one, as you guys saw. Like that thing was just like kicked Allen Bradley's butt. So nearly universal there. So Profibus was used all over the place there. And this is, again, kind of an older standard. Profinet, which we'll talk about at the very end of this, has kind of come up and taken over with that. It's basically replaced Profibus, which is kind of interesting. So that's good enough. All right, but anyway, here you can see an older Siemens PLC. This is an S7200. And if you actually look on the sides there, you can see that we do have actually 2 DB9 connectors. Oh, there we go. Let's focus on that now. Anyway, so you can see we've got 2 DB9 connectors there. They are both, again, that RS-485 interface. So that is how Profibus is being used. And it's actually, to me, interesting that they have 2 ports on there. So one can be used for programming. They could both be used for Profibus. It's really your choice. How this one was used, they were both actually wired up, one to a VF drive. So there's 2 VFDs. Each one had a VFD going to it, which to me, I was like, why didn't they split it off? I don't think they maybe they did daisy chain it. Yeah, you can daisy chain it. Maybe they did daisy chain it. I'm just going crazy here. But anyway, so that is Profibus interface right there. Ooh, wrong way. So it is just an RS-485 interface with some specialty stuff going on it. This is using of the OSI layers. We have layer 7, which is the application. Layer 2, which is our data link, which we're going to be connected through a field bus data link. This combines a master slave and token passing, which is kind of weird. All right. And then we have layer 1, which is our physical. We have 3 different options. We have standard twisted pair, which is our RS-485. Again, that'd be Profibus. We also have fiber optic options. And then you also have a Manchester Bus Power, or MBP, and this has safety enhanced systems for explosive environments. So really depending on the environment that you're in is when you're going to pick which type of wiring system. Most of them are going to be your standard twisted pair RS485 is what it comes down to. Now, the nice thing here, up to 24 kilometers is what you can send Profibus. All right. Holy crap. Now, for those who don't know, a 5K is what, like 3.1 miles? So this is roughly, what, 24, about 5? So about 15 miles is how far you can send this. Now, notice there's a little asterisk on that one, right? This is not going to be over traditional twisted pair over freaking 15 miles. No, this is going to have to include repeaters and fiber optic transmission if you want to go that far of a distance on Profibus. All right, probably not too big of a surprise there. We do have the capability for, again, a wide range from somewhere between 9,600 bits per second to 12 megabits per second. So that's a quite one up there. So remember, 9,600 would be 9.6 kilobits, so it's about over 1,000 times faster. So you have a very large range window here for your speeds. We do have some interesting message sides. So we can have up to 244 bytes of data per node per message. Bytes, that is. Remember, that's 8 times that. All right. Anytime we're talking about bits, and I think I've had this ramble, but I hate how anyone who advertises their internet speed advertises it in bits per second. Like, congratulations, you have a 50 megabit connection. You're downloading something, you're like, well, I'm only getting 6 megabytes per second. It's like, well, once you multiply that by 8, it gets you to 48, which gets you right about to that 50 mark. So I hate how, like, basically everything in the world works in bytes, but yet anything dealing with transmission speed is still in bits. I overall do understand it. It just drives me nuts. What? No, yeah, exactly. They want to be like, yeah, look, we've got 1,000 gigs. It's like, well, it's bits, not bytes. 1/8 of what you're actually advertising. So I'm not concerned, but it's just the way the game works. Anyway, these messages do have 12 bytes of overhead and the max message length of 256 bytes. All right. Yeah, we have a few different options here. So we have a polling and token path for our medium access control. So what that means is we have this set up as a bus, and basically one device says, hey, here's the stuff, and then it passes its token to the next person. And that person goes, here's my stuff, and then it passes the device to the next person. And we just keep doing that around robin. So little circular system going on, which is all fine and good. That works. All right, it might be a bit slower depending on what's going on, because depending on how many bytes or devices you have and how many people are actively like sending information out, there's a lot of information that could be there. So that could be a bit on the slower side. We do have also a master and slave system. So the master obviously would be the control bus. So that'd be the main control. Nice thing here is we can have multiple masters. All right. I personally think that is a necessity in the world we live in, to have multiple master devices. So you can have your PLC, and then when you're troubleshooting, you can hook something else up without having to disconnect your PLC. So that way you could monitor what the PLC is sending out. You can send your own messages. You can check your own stuff. So I think that one is a important aspect. If you do have multiple masters, the masters take turns based on token passing. So it's like a combination of token passing and a master slaves. So the two masters are just passing tokens back and forth, going like, my turn, your turn, my turn, asking for whatever they need. And then the slave devices are just sending out information back and forth. So the slaves, those are going to be typically your peripheral devices, such as transmitters, sensors, actuators, those types of things. Hopefully by now you guys all have a pretty good picture of what would qualify as the slave device. So a slave device can only acknowledge that they received messages or transmits messages at the request of the master. So again, they have no initiation. They can't be like, hey boss, here's some information for you. I know you're going to want it soon. That'd be nice. Like, okay, yeah, thanks. Don't have to ask you. So they're going to be passive stations, is what they come down to. It's they're just sitting there waiting for their request, and they're going, yep, here you go, or yep, I got your message. I'm writing that data now. If you have outputs. All right, now some network types. We typically are going to do a linear or a bus, and by that I mean you've got all your devices, just your master here, and then yeah, there are. Thank you. You guys just been staring at a blank PLC the whole time. But anyway, we've got our master device. Go back. Then we got slave 1, slave 2, and then slave 3. So that's going to be our typical setup for these types of things. So that's going to be your linear bus. You can, however, do star or more advanced configurations. So it really just comes down to the need of the system that you're working on. I would say most of these Profibus systems are going to be in a bus pattern. It's just going to be a straight, one line to the next, and most likely it's just daisy chain. So you've got, I said how we had it. We had our PLC here, and we had VFD1 and VFD2, and the wire literally came here to connect to that, and it literally just jumped right back to the next one. So I think the wires are, in the same screw terminals and everything. I don't think this was like DeviceNet where the terminals had their own screws. They might have, but I don't remember. The other really interesting thing to me was on the, and I wish I had it with me, but it's at home. On the connector, the DB9 connector, you plugged it in this way. But over here, there was another DB9 connector, and there was a little toggle switch. And I think that toggle switch actually connected the DB9 to the cable or the DB9 to this for like programming purposes. So if you only had one DB9 connector like on your PLC, you didn't have to unplug all your VFDs or whatever the Profibus network is to program it. You just flip the switch so it would, change where the information was coming from. So you could plug in, program, and then flip it back and send it back to your VFDs, which to me is kind of nice. So it was definitely interesting. If I remember, I will bring that in next class so I can show you guys. It was one of those things I meant to grab before I left my house this morning and completely forgot. So the way the game works sometimes. All right, so now Profibus has multiple different types. We have FMS, which is our field bus message specification, DB, which is our decentralized peripheral. You can have a combi mode, which is FMS and DPU. You have PA, which is process automation, and then you have Profidrive. Wow, I'm just like, there we go. Why do we have just so many different standards within a standard? Like, it just drives me nuts. I understand revisions, but this is just a little crazy to me. But anyway, Field Bus FMS. This is the initial version. This was the brainchild. This was like, we're gonna create this awesome technology. We're gonna blah 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 blah, and they made it, and they went, damn, it's not flexible enough. Doesn't do everything that we want it to do. So it still is used every once in a while. It was originally designed to communicate from the PC to the PLC, or PLCs maybe, if you're getting them all on one network. And the biggest, one of the big downside is the FMS messages consume more overhead than the central peripheral one, the next one. So it worked, it got the job done. But then when someone went, hey, can we put a VFD on this? They were like, probably, we probably don't want to do this. All right. So there was kind of an issue there. Not the biggest problem in the world, but it's still a problem nonetheless. This led us to the decentralized periphery, which used with PLCs. So this is one that's most often used, is Profibus DP, if you're looking at these. There are 3 different versions, 0, 1, and 2. So not only are there 5 different versions, there's now 3 subversions of DP. This does allow multiple master devices. All master devices can read states from slaves, but can only write to slaves assigned to them. That's a big if, or a big asterisk. If you're reading this, you're like, oh, we need multiple NAS. Okay, cool. Well, again, you have to have them assigned to you. You guys remember we talked about DeviceNet? Yeah, we talked about DeviceNet. We had this hard out. You had to have that file set up so that way, the PLC know all the information about all the devices. Well, you have to have a file just like DeviceNet. So we'll come back to that in a little bit. But anyway, so you have to be able to say this, this slave device is yours. I'm assigning it to you. So you can read, you can ask any slave you want questions, but you can't write to anybody. So again, that may be perfectly fine for your situation, or it may not be. So something to think about. This is a good alternative to 4 to 20 milliamp signals. So if you're doing analog stuff, this is a good alternative to have a device, a Profibus, device at the end of that network, just like a pressure sensor or whatever that's just hooked up via Profibus. So instead of having to run analog stuff, you can do that. And typically we're going to have less than a 10 millisecond bus cycle time. So pretty stinking fast. Now, we did talk about like really early in the semester how like, sometimes 2 to 5 milliseconds is as fast as we have to run these things. So obviously 10 millisecond, not going to be quick enough. But it really just depends on the situation that you're in of how fast it is that you need to go. Combi mode. This is an FMS and DP used simultaneously. That's really screwy if you ask me. This is most commonly used when both PLCs and PCs are being used. So if you are if your main device is going to be a PLC connected to a whole bunch of sensors and whatnot, but then you also need to have your PC hooked up, this is when we're going to go to combi mode. All right. It's a little probably confusing, but it's the way the game works. The PLC and the PC, they're going to communicate with the field bus message spec, and the I/O devices are going to use the DP, the decentralized peripheral, to talk to the PLC. So it really just comes down to what are you trying to talk to and which mode it goes into at that point. Process automation. This is used to measure equipment via process control systems. This is designed specifically for hazardous environments. So we have hazardous, process automation might be your best option. This does normally operate over the RS-485 twisted pair medium. However, this can also do the Manchester bus power. So it really comes down to your specific preference at that point. Overall, this is the same as the latest Profibus DP version 1 with diagnostic extensions. So not a huge difference there, but there's some slight modifications to make it better suited for hazardous environments. That's all it comes down to. And then last we have Profidrive. This is created for motion control applications. All right. Now, when I say motion control application, what comes to your guys' mind? Yep. Motion sensors. I mean, okay, we might have some sensors on there, but not necessarily just sensors. Drives. All right. Yeah. Notice it even has the word drive in it right here. This is mainly for thinking we're dealing with like VFDs, high precision of things, those types of things. You're going to be rocking some steppers for precision stepping, those types of stuff. That's where Profidrive comes in. Good example of this is a company, I don't think it's local. I think this was just something I was reading or watching. They had an X-ray scanner scanning, their process going through. And instead of having a whole bunch of X-ray scanners set up, like, down the line, so this one does this 1 foot wide section, the next one does the next foot, the next one, they actually had the X-ray on a conveyor that went back and forth on a track. So that would be your motion drive. They're very precisely positioning it as they're X-raying, so they know where they are at any point in time, so they know where that X-ray was taken. So move it back and forth. Sometimes you're going to be back and forth, in and out, up and down, whatever the case. So, you could have 6, 12, 8, 12, whatever different axes. If we look at the robots around the room, the ABBs, those are all 6 degrees of freedom. So there's 6 different axes there. So there's a motor and an encoder on every axis. To me, that's just a little bit on the nutso side, but that's just the way the game works. So, Profidrive. All right. If we're going to talk about the physical layer here, we've got a few different things. First, you can see our speeds versus distance. So if you want that full 10 meg, only 100 meters, about 300 feet. Still, 300 feet, that's a long distance if you want to think about it. This room is probably, maybe 30 feet across, so 10 of this room long. To have one PLC communicating down 300 feet, that's a lot. All right. Now, I'm not saying it's impossible that you might have something like that set up, but the probability is much lower in my official opinion. Another great use for Profidrive is if you were doing multiple PLCs or multiple conveyor belts, right? And you have a part that gets transferred from this one to that one. Well, if you had a sensor here that was wired up to your Profinet, this was your slave device, it could talk to this PLC saying, hey, the part's been loaded, you can stop this conveyor, but then you can also talk to this PLC saying, hey, a part's been loaded, start the conveyor, type of thing. So you don't actually have to directly network those PLCs together. You can just have one sensor that's on the same bus talking to both of them, which is a very useful tool to have. Man, passing things from one PLC to the next is a task. All right, because it's like, okay, how do I know when it's there? And it's like, well, if I have a sensor here, yeah, that's good to tell me that it's past this point, but then this sensor can't talk to that conveyor, so then I have to have a sensor here saying, hey, turn, so you're like having to add two sensors for the exact same purpose. Well, if they're on the same Profinet or Profibus, you could have them both talking to both, with one sensor talking to both, and only have to have one. So, a little give and take going on. It is passing things from one PLC to the next is definitely a task in itself. All right, it can be simple, but it's also hard because it's like I have to be able to say, hey, are you free for me to pass something to you? And then you have to tell me, yeah, I'm free. And I have to say, okay, I've passed something to you. And then you have to tell me, yep, I got it. Stop passing me things. So there's definitely this two-way communication going on from one PLC to the next. It's not like a simple like, yep, here we go, here's your part. Because if that's not ready for that part yet, then it's got to wait. So just kind of something to think about. But anyway, so 100 meters up to 1200 meters, and we're downward to, again, 9.6 kilobits or 9600 bits. We do have this terminated on both ends again. Probably no big surprise there. Twisted pair, again, shouldn't be anything too crazy or surprising in that aspect. So here we have some performance, which is also very interesting to me. All right, so here you can see bus cycle time on our vertical, and you can have a number of DP slaves on the right. So obviously, a short reaction time is our goal. We want to have the shortest time between a sensor tripping and the PLC being notified of that. Notice this is also in milliseconds, so it can be really slow or really quick. So if you're running 12 megabit, even with 30 slave devices, we never get over 2 milliseconds. You can transfer a lot of data over 12 megs, and when it's just like, a few hundred bytes. That's kind of crazy. If you go down to the slowest at 500, though, notice we're all the way up to like the 18 millisecond time. So it is definitely something that you want to be aware of. And notice right here, there's like a very, to me, like a very obvious direction change. Not quite as bad as I drove it, but it's like a pivot point. It's like, oh, you got over 10 devices, we got to add an extra header frame or something like that. So it instantly adds more time. So that is something that you want to be aware of. For the 1.5 megabit, to me, it looks like it's around the 5 point that it adds more time. Again, drastically kind of like shifts. So just something that you want to be aware of. So a quick example. 512 inputs and outputs distributed over 32 stations can be accessed in 6 milliseconds at 1.5 megabits per second or 2 milliseconds at 12 megabits per second. 512 IO being checked in 2 milliseconds. Just think about that. Well, I'd say as a human, I don't think we're even that quick. I love watching slow-mos of things. When someone like pops a balloon and you watch the slow-mo of the person and it's like, it just feels like ages before they react to like the loud bang that just happened behind them. It's like, yeah, but the PLC, it can do 512 of those like reactions in 2 milliseconds. Like, it's done. It has to be like, you pop the balloon, it takes like 2 or 3 or I don't know, 10, 15, however many milliseconds before you actually register the balloon is popped and you're scared by it. So that one's interesting to me. Yeah, so the main service that we're using to get these results and get them so quickly is going to be that layer 2 of the OSI model. So we already talked about that a little bit. This does allow us for the transmission of the input and output data in a single message cycle. So that's good. And anyway, 12 megabits is going to be the best option. Increased performance is going to be the number one. All right. As I said, though, the biggest downside of that is your max range. But again, to me, 300 feet, that's plenty. Like, if I have to run a network more than that for one single PLC, I'm starting to get worried. All right. Now, unless you're like, well, we're going to have an HMI at the end, and that's going to be on Profibus. Then I could start going, okay, you're going to have to run a Profibus from here to the control room, and that's, 1,000 feet away. that one I could say, okay, I understand why you need to go that far. But like for a VFD or IO or whatever, being more than 300 feet from that PLC to me is a bit nuts. Unless you have only like one PLC running an entire facility, and then I'm calling you crazy for doing that because uptime is key, and one PLC, one single failure point that takes the entire facility down, no bueno. All right. All right, so configuration. So we have master class. Anyway, at the top, we've got our master, and then we've got all of our different things going on. I love the fact that some of this is in German. So decentralized inputs and outputs. So your DPM1, that is typically a PLC, all right? Your DP2, these devices are used for programming configuration or diagnostics. All right, so that's what we can see down here. We got our PC connected. So that's mainly going to be there for configuring things, diagnostics, those types of stuff. So very useful, but not necessarily having to be there. And then your slaves, those are going to be for your sensors and action and whatnot. Okay, so you can have a mono master system. Again, just one single master device, one PLC controlling everything, or you can have a multiple master system. And again, notice down here, this is kind of weird. We got like a Venn diagram going on, but we don't have the overlap right here in the center. All right, so we have a master device, which is one PLC. To me, looks like a freaking microwave, or sorry, CNC. Looks like a microwave to me. How about you guys? And then we've got our master SPS system over here. So this is saying this is a master of these decentralized I/O. This is a master of the actuator, sensor, and this decentralized I/O. But remember, this one can still talk to all of these things, and this one can still talk to all of those. It just can't write to them. So the magic write line where we have to stop communicating or stop writing information is right here. But it's still able to read against everything. And again, thinking about like a CNC machine, a robot loading it, being able to say that the CNC machine's done and waiting is a great thing for that PLC. It doesn't need to tell the robot, hey, do something. No, it just means to be like, oh, thanks, you're done. I got you. I'll unload that. And then the CNC has a sensor or whatever that says, hey, the part's been unloaded. And then they can tell the next, hey, put another part on me type of thing. So a little bit of give and take going on there. We have multiple different states. So some of the standard ones, the stop state, probably not too surprising that there's some sort of stop state. In this state, no data transfer occurs between the DPM1 and the DP slaves. So just no communication at all. It's just there, it's done. We're not doing anything. We're just kind of waiting. You have a clear state, and this is when the DPM1 puts the outputs into a fail-safe mode and reads the input device data from the DP slaves. Fail-safe modes are always going to be important. All right, same with a reset system. This is definitely one of those things that like I don't put into my code. I'm not programming like some crazy things. But being able to reset your system is going to be super important because think about that. You're running your system and a piece gets stuck in the system and it breaks. Well, if you just remove that because it's broken, you're like, okay, we'll hit go again. Well, that one station is expecting that DVD box to show up, and it's never going to show up. So it's just waiting for it, and everything before it is waiting for that one to do something. So you need to be able to say, yep, reset, remove this item or whatever the case is. All right. Again, local company with the countertops, they, if something happens to one of the countertops in the line, they have to be able to remove that countertop from the line. So that way the next one that gets processed, the following machine doesn't think it's the one that got removed and cut it and foil it and do whatever at the wrong places. And then they just have to throw that countertop out as well. So because they're making different countertops every single batch, it's not like, oh, we're just going to produce 50 of this one. No, it's we're going to make one of this and two of that and one of here. We're going to use this color and that color and this backing board, and we're going to roll this edge. We're going to have a sharp backsplash, whatever the case is. Everyone's different. So if they don't remove the damaged one from the line, well, now that everything after that just be screwed up. So they just have to throw it all out. So having some way to reset everything in clear states and whatnot is good. Ideally, you can reset just one single point. You don't want to have to reset everything because then everything that was in progress now has to get removed. And depending on your system, that could be hundreds or thousands of dollars worth of product that you're like, well, we had to reset everything, so all of this is now trash. Ideally, you can be like, oh, we took one piece out, and the rest of the system just works perfectly fine. All right, and then we have the third standard mode is, if you're probably guessing, we've got stop or clear, which last one would be an operate mode. Last one. That's when the DPM one is a data transfer state with a cyclic message sequence where input data is read and output data is written to the slave. So this is where it's going, hey, you, what's your information? Hey, you, what's your information? Hey, you, do this. And just kind of repeating that, constantly type of thing. Now, we do have some non-standard options, or standard states. One of them is a synchronization state, and this is when the slaves receive this, they freeze their outputs and enter sync mode, they update their output tables, then they set their outputs. So they basically say, all right, all our outputs are staying what they are, they all get new data, and then they all set them at the same time. That way everything gets synchronized at a given point, magical point in time. We also have a freeze, and this freezes the input states until the next freeze command. So synchronization deals with your outputs, freeze deals with your inputs. Which to me is a little weird, but that's the way the game works. Now, has anybody heard of a watchdog? So, watchdogs are extremely important. All right. Anytime we have something technical, electrical, whatever, there is the possibility that that device is going to just freeze. Not going to freeze state, just like stop working correctly. All right. And if we think about a watchdog, it's something that makes sure everything's kind of going okay, right? At your house, you got your dog, it's your watchdog. If someone breaks in, it attacks the dog, the person, whatever. But watchdog in the same way for the computer system is it's going to make sure that everything is operating as it should. All right. It's just sitting there waiting. Just like, okay, yep, you're going fine, perfect, thank you very much, have a good day. And it just sits there. That's all it does. All right. But what it can do is when it detects that the system has frozen, it can go, is everything all right? And just kind of wait a few more seconds or whatever the magic time is. And it says, it's not all right. And it can reset things. Now it could, again, reset maybe a specific IO module, like a network one, a remote one, or it could reset maybe the PLC, whatever the case is. So so Watchdog is a timer that makes sure everything is operating as it should. If that timer expires, the master is notified and all assigned slave devices enter a fail-safe mode. That's what this is saying, at least. Now, how do we know when something doesn't work? Well, maybe the watchdog is watching for that master-slave communication, and the master's saying, hey, do this, and it never gets a response. And the master device might not have time to wait and say, okay, I'm come back to you in a minute, 5 milliseconds, I'm going to do it again just to make sure. So it could be doing that. In the world of electronic stuff, when you're doing especially like small embedded things, a watchdog is maybe a little chip that just you pulse high every second. You send an output that goes, hey, I'm here, I'm good. And as long as that watchdog is getting that pulse, it doesn't do jack diddly. As soon as that watchdog stops getting that pulse of I'm good, that's when the watchdog jumps in, pulls the reset on the device low or high or whatever the case is to turn anything off, waits again like half a second to a second, lets that line go, and then gives it 30 seconds to a minute to maybe reboot to make sure everything's operating correctly again. So watchdogs are super important when it comes to the world of anything electrical. It doesn't have to be just this or just that, but anything that's electrical that, especially communicating, you could have that problem. There's nothing worse, in my opinion, than having something and have it just stop working. You're like, okay, now what do I do? What do we normally do when something stops working? Plug and unplug, right? Screw you, you just unplug the damn thing from the wall for 30 seconds or whatever. Maybe you press and hold the power button while you're doing that, so that way all the capacitors and things like that, the TV tries to turn on and the capacitors all lose all their charge. And then you plug it back in and turn it back on. You're like, oh, there you go, now you're working just fine. All right. I mean, that's always a good go-to system. When Windows hangs on the laptop, all right, I hate laptops that have built-in batteries because you can't just pull power from it. You just have to okay, let me press and hold the power button. Hopefully that's gonna work. Sometimes it does, sometimes it doesn't, type of thing. So a little bit of give and take going on that one. All right, and this brings us to that wonderful file that I talked about earlier. I talked about how DeviceNet had that configuration file. Well, so does Profibus. And in Profibus world, it's a GSD file. All right. Now, I believe there is a few different flavors of this. So there is the PBGSD. This is for your Profibus master slaves using GSDL language. Yeah, so many freaking acronyms and things like that. And then you have the PNGSD, and this is for your Profinet devices, and this is XML based. But basically, this is a setup file. This is like talking to the PLC or whatever the master device is going to like, hey, here's the devices on the network, here's what you need to know about them, and all this other information, which we'll talk more about in a minute. XML, you've probably all heard of XML before. You probably have no freaking clue what it is, unless you're a programmer / web developer. All right. XML is an extensible markup language. And I actually should have put an example of an XML file in here, but I did not. So here is a very, very simple XML example. So notice how everything has less than, greater than around it, and we actually have what's called an open and a close. So the open is the name, note, and then the close is the /note. To /2, from heading, /heading, body, /body. So they all have it. They all have those matching things. And this is just a way to associate, as this says, style information. Oh, no, this doesn't have style information, just information in general. But we can say, like, you put like vendor here or whatever it is that you're looking for. Some examples of what you might be looking for. It'd be configuration information. So, are we using mode 1 or mode 2 on this device if there is multiple modes? Parameters, type of information are we going to be able to grab? Modules, how many, is it a 1 module or 2 module? Is it a rack? What is going on with this? Diagnostics and alarms. Like, oh, we're having a problem. There's a diagnostic on there, so we know where to check for that information. Who the vendor was, that vendor information, and also other device information. So XMLs can be a super powerful tool when they are used correctly. Here's another example of one that's much larger. But here you can see catalog plant. They're telling you it's a bloodroot plant, and its botanical name is that. Zone 4, mostly shady, is what it likes for light, the price, the availability. And then we have another plant. This one's a colubine, and so you can see it's just grouping everything together. So it's almost like an Excel table, if you want to think about it that way, where like each of these would be a row, or a column maybe. Probably go with a column, and then you put this in the row, type of thing going across a bit. So you could just kind of group it all in a nice Excel file. In that case, we'd call it a CSV, most likely a comma separated value, but this is just done it slightly differently. So it really comes down to what you need. The nice thing is learning these XML files and things like that is they're used all over the place. And how I'm showing you guys stuff on the TV, it's called OBS. It uses XML file formats for its configuration files. So earlier this semester, I was modifying XML files so that way I could get this whole thing to work correctly. Happens just to be the same language that this is using. So a little bit of give and take going on is what it comes down to. So it is the extensible markup language, just saying that again. This is similar to HTML, so if you've ever done any website coding, that will look very similar to you. However, it does not have predefined tags that you have to use. So as you guys saw, anytime you saw a, this, and it was plant in this case, that's your tag. All right, plant is the tag. So you get to create whatever freaking tags it is you want. Where in the HTML world, it's like, oh, it has to be a header or a body or whatever the case is. All right. This you have to define them. You're like, plant. All right, I'm just gonna start plant. It's gonna, basically be its own little tag. So the nice thing there is you can define your own, and it's specific for your needs. So that's why they liked XML for this. They didn't have to say like, oh, we have to follow this certain format. No, it's like, okay, we're going to follow somewhat of a format, but it doesn't have to be a specific one for HTML or whatever the case is there. Now, the other thing I saw that the file name for this GSD file actually had some requirements, which I thought was rather interesting. Normally we think about file names being like whatever the hell we want to call something. And I don't like the fact that if this is true, file names have to have all this information. That just seems like it's going to be a super long file name. It's going to be very confusing for people. I'd rather just be like the top line of the document be this type of thing. But the file name should have the version of the GST spec that the file adheres to, for example, version 2.3. It should have the vendor name, the device family, and the date. And like personally, I'm gonna be like assembly line 1. Like that's what I want to call the GST file. And then again, like the first line of GST file, I could put all this information. I'd be perfectly fine with that. But that just seems like a lot there. There is a GST checker that will show you the contents of a GST file for Profinet, which is nice. It also contains a function to check the accuracy of the GST files. And this is free. Holy crap, unlike Alan Bradley, where it's like, oh, you have to buy our file creation software so you can actually use your DeviceNet stuff, even though it's an open standard. Like, okay, thanks, Alan Bradley. This one is free. Like, you can just go to their website and just download it, which is kind of nice. And that would be Profinet University, if anyone is curious there. Yeah, there was a lot going on here for the Profinet University. You've got your basics, you got all sorts of real-time fun, interesting stuff going on here. Real-time stuff. Here's the GST file basics, and it does not. It's a checker tool. So you can just go and download the checker tool, and you can see what's going on. So really quite nice in the long run. So that's, to me, is definitely a little bit on the better side. Now, here we've got some information just for you guys. So the primary vendor of Profibus is Siemens. We've already talked about that one. All right, the primary advantages, the very fast and simple integration of Siemens PLCs, because it's built right into the software, which is great for any type of communication you need to do. Disadvantage, no power on the bus. So all we're doing is sending signal. Unlike DeviceNet, where you had power for the bus, for those bus devices, as well as data. So a little bit give and take going there. This does say expensive connectors. DB9, I'm not going to say that they're like, outlandishly expensive, but they're, to me, more expensive than they should be. Up to 12 megabytes per sec, max frame size 244. We've already hit those up. It says there's an advanced connector for the Profibus speed. All right. Remember 2 types of messaging capabilities. If I say the word duplex, what does that mean to you guys? Right. Duplex means that you can have bidirectional communication happening at the same time. All right. So if you have half duplex, that means only one device can communicate at a time. So that is a big thing to think about. Serial communication is duplex. You have a send and a receive line. So you both can be sending information at the exact same time and not have data colliding in somewhere. Where a lot of these bus type systems, they are not full duplex, they're only half, because only one device is able to occupy the communication lines at a time, because they're sending a message out. Normally it's differential signaling, that's why there's 2 wires there. So it is important in that type of thing to have, just something to keep in mind. Basically, you can't have like your master device talking and you guys, excuse me, I gotta go potty, and like walk out the door. No, it's like, oh, you have to wait, and then all of a sudden, an accident happens, and then you can finally ask to go to the bathroom, type of thing. You can tell I have kids. All right. Anyway, yeah, sponsoring organization, Profibus. Now, as I did say, we have Profibus, and now we have the wonderful world of Profinet. All right. This is based off of Ethernet. Surprise, surprise, right? It's got the word net built right into it. All right. So this is just something different to think about is what it comes down to. So I showed you our old school, what is this, the S7 200 PLC there. I don't know how old school it really is. That's actually a brand new PLC that's never been programmed as far as I know. I just don't have a programming cable for it. And software. It's the other fun one. But anyway, Profinet based on Ethernet. Usually it's going to have this bright green cable. I've got a whole bunch of those in the back of the room. Does it really matter? No. Like any standard Ethernet cable will work. Benefit, I believe, to the green cables we have in the back of the room, I believe there's shielding on the outside. And the connectors are actually kind of metallized. So again, the shielding actually connects to the Ethernet port for shielding purposes. So normal Ethernet cables do work, but just something to be aware of. We have a consumer model instead of a master slave. So we have controllers and devices. We don't have like a, hey, give me information. So something to think about. We also have network switches in this. Again, standard old Ethernet switches work beautifully. So any device works. I've used like home routers. You know, the router that you have powering your Wi-Fi at home, I have those that I'll plug these things into. Works without a problem. They do need to be 100 megabits, full duplex or better. So that is just something that you need to keep in mind. A lot of times you're like, oh, PLC, we're not transferring that much information. If I have an old 10 meg segment, whatever, it'll be perfectly fine. Probably not the case. You really want to get that 100 meg or better, which in today's world, I don't know anybody that sells a 10 meg. All right. A lot of times, especially if you're buying a computer, the Ethernet port will say, you know, 10/100, maybe even now /1000, or even higher now. So you can have 10 meg, 100 meg, 1000 meg, or gigabit. I think they're starting to get to 2500. It's starting to become not standard on motherboards yet, but like on high-end motherboards, it is starting to become standard. And I'm like, why does anybody need 2.5 gigabit network speeds in their home network? How often are they transferring that large of a file from one computer to another that makes sense? And I still don't have an answer. Doesn't make sense to me is what it comes down to. I personally do not have that big of a need for 25. You know, my server and my desktop sit all 6 feet apart. And I do have a gig network connection. And I do transfer video files and photos and things like that back and forth to them. So in that case, I'm like, great, I'm glad to have it, but I don't truly need it. It's not like I'm doing it every day and it just sits there transferring files all day. So, but anyway, this does support the capability for wireless local area networks. So wireless, you know, our wireless we have in here, and Bluetooth as well. So you could do a Bluetooth network, which to me is kind of crazy. Why you want to do that, I've got no stinking clue. All right. Earlier in the semester, I believe we talked about how industrial environments are super noisy, and doing those types of communication is not normally suggested because your Wi-Fi doesn't go very far. Bluetooth itself doesn't go far, maybe what, like 30 feet by itself, and that's on like a nice, beautiful area with no interference. Add on interference, it's probably down to like 4 or 5. Also, I don't know about you guys, you know, wireless headphones. I could have my phone in my left pocket, like turn my head to the right where my wireless receiver is, and lose signal. I'm like, 3 feet? Like, you can't keep connection over 3 feet when my body's in the way. So, Bluetooth, definitely not what I would suggest, but maybe there's a good reason for using Bluetooth. So, wireless maybe, but I'm a big fan of wiring things, which, yeah, if I can run an Ethernet cable somewhere, I will. I've tried to figure out how to get an Ethernet cable to my TV, but luckily it's got a brick wall on one side, it's got, you know, an exterior wall next to it, so it's got full of insulation, so it won't be easy to sneak an Ethernet cable up through it. I'm like, oh, can I come down from the top? But my roof is so shallow pitch that I can't like get a drill to the wall to try to, you know, get something in that corner. So coming up from the bottom, there's concrete because it was a fireplace. So I'm like, I can't get a freaking Ethernet cable there without like cutting out drywall, which before we paint, I might do. Might run an Ethernet cable there because it makes sense to me. But anyway, so that's good. So here is just a little quick comparison of them. They both have the same organization. They both have the same profile for the application. Both have the same concepts. One is based on RS-485. That is based on Ethernet. Notice our speed differences here. All right. Notice our telegram size. So 244 bytes versus 1440. So that's a big difference. Address space unlimited for Ethernet. 126 for Profibus. Different technology for how we're communicating, master slave versus provider consumer. Profibus versus mini buses. Profibus technically is capable of wireless, but not really suggested. The Ethernet Profinet is both 150 accesses, so there's a lot going on here. But the real thing here is Profinet exists because PLCs don't have Profibus connectors. If you ask me. All right. They said, this is antiquated technology. Let's get out of it. That's kind of how I saw this. You know, the writing on the wall here type of thing. It's like, all right, we're going to put Ethernet ports on. We're not putting DB9 on it anymore. Let's just go to Profinet. I mean, there is our communication port right there on this Siemens PLC. I can open all the flaps up, You'll see nowhere is there a Profibus DB9 connector. You could probably get one, a module that would sit right here on the side of it that would have a DB9 connector on it. I think you're allowed 3 networking interface communication interfaces on the left of this as external modules, 2 or 3. So you could probably get one if you really needed one, but it's not something that I am seeing. Now, the fun thing here is, since these are open standards and overall pretty easy, the nice thing to me is at least that, bring the camera back over. Oh, and now I froze the camera. This button, that button. Arduinos with Ethernets can be Profinet devices. I haven't tried this yet. This might be something we're doing next class. So I've got a few of these with Ethernet ports on them that if I'm like actually get it tested and figure out how to program these things, we may be trying to hook a PLC up to a Profibus, Profinet Arduino, because why the hell not? That's really my reasoning for doing this. It just seems like something cool and fun to do. Yeah, I don't have a great reason why anyone would really want to do this in the industrial world, because, well, again, just because you can doesn't mean you should, is really what it comes down to. Except for when you're in a classroom, it's because we can, it's because we should. That's kind of my reasoning here. But in the world of industry, yes, let's jump on the bounces program. Look at that. Yes, this device could work perfectly well in your industrial application. The problem is when everyone's used to PLCs and you replace it with a little itty bitty Arduino, it works great for a month and then something happens. Nobody at your company knows how to fix this thing but you. Now your boss is pissed at you because they had to shut down for the day because you weren't at work and this thing broke. So this is not the type of thing that you want to rely on unless everybody in your company knows what the hell is going on with it. Big benefit here is this is like a $10 board compared to a $1,000 PLC, and the software is free. Downside is there's not as good monitoring for it. Most Arduinos you can't like see what's going on the code, where the PLC we can go, oh look, this output's on right now, and I can see that in the code. And why is it on? Oh, because these things are true. Doesn't exist on most Arduinos. I think there are some with those debug interfaces. I don't know if there are Arduinos though. Other microcontrollers, yes. But it's just, to me, something really interesting. So, but yeah, we may be getting these out next class, hooking them all up to some PLCs and trying to like read data and write data and see what we can actually do with it. Just to, again, kind of like show you guys how the Profinet, because setting this up as a Profinet on the PLC is the same as setting any Profinet device up. It's, got to configure it correctly over there. So it doesn't matter outside of that. All right, gentlemen, that is all that I have for today.